Hi math students, this video is to help you with your upcoming checkpoint. So what you should do is write down these notes along with me, or I also attached a picture of this page to this video so you could print this page and fill it in if you want. Either way, write it down on your own paper or print my page and fill it in, but you need to make sure you write down these notes and then you can use this page when you do your checkpoint right after this video. So this is really helpful to do. Okay, so domain and range, that's what this lesson was talking about. So domain are all the X values, or you could think of them as like input values, like we talked about in the last lesson. Range is the Y values, or the output values. And you could always pause this video so you have enough time to write. I'm just going to talk quickly so I can get through everything, but pause the video anytime you need to. So anytime it asks you what the domain is, think about that as X values. If it asks you what the range is, you think about that as Y values, okay? So the domain, so if they give you a function like this, f of x equals negative 1/3 x plus 5, they might ask you, what's the domain? So what numbers could we put in for x? Well, we could put any numbers in for x that we want. All real numbers. We could put anything we wanted in here and then multiply it by negative 1/3 and add 5. We could put anything we want. So the domain would be all real numbers. And the range, what numbers would come out of this function? So when I put all these numbers in, what numbers are coming out? Well, actually, any number could come out of here. So I'm going to say all real numbers. So I'm going to show you what this looks like on a graph. So if I wanted to graph this, and hopefully you're familiar with how to graph these things in slope-intercept form, I'm going to start at positive 5, 1, 2, 3, 4, 5. And I'm going to follow my slope down 1/3. And I can do that as many times as I want. So my graph ends up looking something like this. So when you're looking at this graph, here's my x values, right? This is my x-axis. So this shows that I can put any x value I want in here. Any of these numbers can go into this function. And this graph just keeps going and going. And for my range, my y values, so looking at the y-axis, any y value can come out of this thing. And it would keep going up here as we get taller. It keeps going down here as we get lower. So the domain and range are both all real numbers for this linear function. Okay, what about f of x equals x squared? So the domain, what numbers could I put in? What values could I put in for x? Well, I can put anything in again. So all real numbers. I can put anything I want in there. And the range, what's going to come out? So this one's a little trickier because I'm squaring it. I'm multiplying it by itself. If I put in a positive number, like let's say I put in 5, I would get 25, right? So if I put in a positive number, I get a positive number out. What if I put in a negative number here? If I put in negative 5, so negative 5 squared or negative 5 times itself, that comes out also as positive 25. Remember, a negative times a negative is a positive. So the only thing that's going to come out of this function are positive numbers. So I'm going to say that the y has to be greater than 0, greater than or equal to 0, because it could be 0. We could put 0 in, and 0 squared is 0. So it's going to be all the positive numbers. Y is going to be greater than 0. So if we look at that on a graph, when I graph x squared, it ends up looking like this. And you've probably seen this before. This is called a parabola. It's the graph of x squared. So what this shows is that I could put any x value in that I want. I could even put these ones in. We can't see them right now because this graph isn't getting tall enough. But I can put those in there as well because this just goes on and on and on. And eventually it would get to these numbers over here. But for my range, my y values, the only y values that are going to come out are these positive numbers. I'm never going to have something down here on this graph because I'm squaring it. So that's what the range would be for that problem. Okay, what if they give you a graph and they ask you what's the domain here? So whenever you look at domain, remember you're thinking a domain is x values. So what are the x values here on this graph? So I'm looking at the x-axis. So they gave us a partial graph here, or a partial parabola almost. So the only x values that work, it looks like it works for x equals 2 and everything greater. So my domain would be x is greater than or equal to 2. And it is equal to 2 because this was a solid dot here, so 2 is included. On this graph, here's just this line. Notice there's no arrows that continue this graph. It's just this thing right here. What's the range? Range means y values. So I'm looking at my y-axis. So the biggest y I see is this one right here, 4, positive 4. And the lowest y value was negative 1. So the range, my y's, it's going to be greater than negative 1, but less than 4. So I'm going to have it like this. Less than or equal to 4, and y is greater than or equal to negative 1. So you can write it like this, like a compound inequality. So if you look at it like this, this says y is greater than or equal to negative 1, and this one says y is less than or equal to 4. Okay, if the range is all real numbers, the equation cannot have what? So range means y values. So if the range is everything, like all the y values can be included, you cannot have something like this. Remember this x squared? When I had an x squared, that excluded all of these lower values here. So I'm going to write in here, right here, x squared. You could not have this x squared if the range is going to be all real numbers. The only way that the range, the y values, is all real numbers is if we have this linear function or not having an x squared. So hopefully you wrote all of those down and you can use them on your checkpoint right now.